up here. But if you guys want to open up your Notability, and I'm going to start with a new part of our notes because this is kind of a different topic. So when I'm done, I will label this graphing trig functions. So let's put that up at the top now. And I'm going to approach this a little bit differently. I'm going to just kind of show you what they are, and then as we move along, explain the why behind it, okay, as opposed to vice versa. So the two most famous trig functions are sine and cosine. So when it comes to graphing, we're going to focus on those. We will do some tangent stuff, but we're going to start off by focusing on the sine graph and the cosine graph. So I'm just going to give it to you, and then I'm going to explain, why it is what it is. So if we wanted to graph y equals the sine of x. All right, I'm going to draw an xy graph. And I'm going to put 4 dashes along the x-axis. Those 4 points are, really important. They are kind of either x-intercepts, or they're going to be minimums or maximums. So those are, when you're thinking about the unit circle, those are the quadrantal angles, or like straight up, straight left, straight down. So the first dash is going to be at pi over 2. The next dash is at pi. The third one is at 3 pi over 2. And the next one is at 2 pi. And then my y-axis, I'm going to put a dash at -1 and +1 on the y-axis, okay? Sorry, just sending a message here. Now, the sine graph looks like this. I'll draw it in blue. I know that the sine of 0 is 0, so I'm going to put a dot there. And I know that the sine of pi over 2 is equal to 1. So I'm just giving kind of, things that I'm going to use as guidelines. The sine of pi is 0, so I put a dot at pi and then 0. The sine of 3 pi over 2 is -1, and the sine of 2 pi is 0 again. So the graph, one part of a sine graph looks like this. All right, that in fact is what they call one period of the sine graph. And it keeps going, actually forever and ever. So, after 2 pi, it does it again, and it does it again. And like going to the left, it does it again, and it does it again. And it just has this wave function, and it just wiggles and wiggles. But, if you really focus on this part here is one period of the graph, then it just repeats itself. Okay, and the reason that is, we can talk about that for a minute. If we think about the unit circle, and remember that, the sine is the y value, and the cosine is the x, of course, so we'll do that in just a minute. But if we were moving along the unit circle, my y value starts here at 0. That's like indicating this point. That's like your starting point. Your y value is 0, then your y's get bigger and bigger and bigger and bigger to here, and then they equal 1. So that is why then at pi over 2, it equals 1. Then your y values get smaller and smaller and smaller, and they're 0, and then they go negative, 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 down to -1, and then they come back here to 0. Okay, that's what's happening on this blue graph, is that it starts at 0, it goes up to 1, it comes down to 0 at pi, then it goes down to -1, and then it goes back up to 0 at 2 pi. And so what we're doing is taking like the unit circle and stretching it out in a linear way, okay, stretching it from left to right. But if you think of the unit circle, then it just goes around again, and then it just goes around again and goes around again. And that's why this graph just goes again, then it goes again and goes again, and it's periodic. It just continues over and over and over again, okay? So that's a sine graph, a basic sine graph. A cosine graph, so if we wanted to graph y equals the cosine of x, it looks really similar. So the nice thing is when you're graphing these, I'm going to do the same thing. I'm going to put 4 dash marks, and those dash marks are going to be like one period of the graph, okay, one loop around the unit circle. So the first dash is still at pi over 2, and the second one is at pi, and the third one is at 3 pi over 2, and the fourth one is at 2 pi. And my scale for the y-axis is the same also. Okay, but the graph, it looks similar, but it's not the same. All right, so here's what a cosine graph looks like. A cosine graph doesn't start here like the sine graph does. A cosine graph starts up here because the cosine of 0 is equal to 1. And then the cosine of pi is equal to 0. I'm sorry, the cosine of pi over 2 is equal to 0. The cosine of pi is equal to -1. The cosine of 3 pi over 2 is equal to 0. And the cosine of 2 pi is equal to 1. But we again get this periodic wiggle graph. So it starts at 1, it goes down through 0, okay, then bottoms out at -1, then goes up through 0, and then reaches the peak, and then it starts over again. Okay, it does the same thing over again. So sorry, I'm just retracing that. And then it would continue in both directions and so on. But this, starting from that top and going down, this would be one period of that cosine graph. And then it repeats, and then it repeats, and then it repeats. And let's think about looking at the unit circle, why that would be. Well, the cosine graph, the cosine at 0 is equal to 1. That's right here. That's indicating that point. And then cosine is x values. Your x values are getting smaller and smaller and smaller and smaller, and then x is 0 right here. So x is 0 right here. Then your x's are negative, and they get to -1. That part is indicating this part of the graph. Okay, then your x's start getting bigger and bigger back to 0, and then they go to +1. So they started at 1, went down to -1, then they went back to +1, and then it would repeat, repeat, repeat as we go around in circles. That's going to make another wave, another wave, another wave. All right, so we have our basic sine and cosine graph. So are we doing okay so far? Can you give me a yes or no, just like you did before? Give me a yes or no. This is good. Good feedback. Come on, everybody. You got to vote yes or no here. Remember, you go down, click on participants, and then click on the yes or no button. There we go. All right, good. So this means that we're understanding so far. All right, well then, we're going to also do some transformations or ways that the graph changes. And so to do some transformations of the graph, I'm going to start with a basic sine graph, but a cosine works the same way. So for transformations, okay, for a transformation of sine or cosine for that matter, I'm going to give you this equation. Y equals A parentheses sine of bx and then plus c. So sometimes the parentheses is written, sometimes it's not. So I just kind of like to show you it both ways, just in case you were, to look at a different resource. And in fact, sometimes you will see it even written this way. And I'm going to ask you guys to erase, and we're going to leave it this way. Bx plus c, and then plus d. All right, and it may oftentimes be written this way, so I'm going to refer to it like this. But there are lots of variables, okay? We have an A, we have a B, we have a C, we have a D. So the ones I want to focus on are what changes the amplitude of the graph. The amplitude is how high or how low the graph gets. So the amplitude for the sine graph is 1, okay, because it goes up to +1, down to -1, up to +1, down to -1. Well, if you put a number in front of a sine graph, the A value is going to change the amplitude. Okay, for example, if I had y equals 4 sine of x, the amplitude of that graph is going to be 4. Meaning when we graph it, it's going to go, instead of from -1 to +1, it's going to go from -4 to +4. So that sine graph is going to start here, but then at the first notch go up to 4 and then down to -4. So that sine graph would look like that. Okay, it changed the amplitude, it changed how high and how low it got. And again, that came from the number out in front. Okay, the absolute value of that. If it's -4, if that was -4, the amplitude is still 4. It's always the absolute value of that. Now, the B value, that affects the period. So how long it takes to repeat itself. So it kind of squishes it a little bit. So, for example, 2 pi divided by, that's a really bad pi symbol, 2 pi over b is equal to the period. So if I wanted to graph, let's say y equals the sine of, let's say, 6x, that means the period, meaning how long it's going to take to repeat itself, the period would be 2 pi over 6. Which is pi over 3. And what that means is the graph is going to repeat much more quickly than it would before. So let me show you on our original sine graph, okay? This repeated every 2 pi. But if it repeated every pi over 3, well, pi over 3 is, somewhere in here. That graph is going to look more like that. It's going to squish it. And the way we can show that is we just really get to pick the scale. So I'm going to make my sine graph, but now my period, I have my 4 notches, but my period is going to be pi over 3. And so my sine graph is going to start at 0. I should write it in blue like I did before. Start at 0, go up here, come down, and it's going to repeat every pi over 3, not every 2 pi now. So looking at our numbers here, this number in front affects the amplitude, how far it stretches up and down. This number here affects the period, so it crushes it horizontally. This number here, the D, that affects a vertical shift, so that'll just shift it up or down. So D is equal to the vertical shift. And vertical shifts really aren't so bad. Like, for example, if I wanted to do y equals the sine of x, and then I had a +1 on the end. In fact, let's make it a +2. That's just going to take the sine graph, the original one we had, and move it up 2 units. So our original sine graph, it's going to be just taking this thing and shifting it up 2 units. So it's nice on the iPad to do those. To graph that, I'm going to draw my sine graph and my 4 notches. It goes to 2 pi. And my amplitude is still 1. So my original sine graph is going to look like this, but I'm going to grab it and move it in just a second, okay? That's the original sine graph.
Mr. O'Connor, I don't really get this.
Get which one? The original sine graph?
No, it's just kind of confusing for me in general.
Okay. So we want to, this is like our parent function, okay? So this is just our regular core graph. So we're going to graph the sine of x, and the sine of x always looks the same way, okay? We're focused on this part of that sine graph. So it always has a period of 2 pi. So you're going to make, when you graph it, you have 4 notches, and the last one is going to be at 2 pi. And for right now, we just want to know that it's a wiggle that repeats every 2 pi, and it goes up to 1 and down to -1. So that's the basic sine graph. That's like our parent function. But then when you start to place numbers around it, so if I put a number out in front, that's going to change the graph. That's going to affect the period, meaning it's going to stretch it this way. Or if I put a number here, that's going to affect the amplitude. It's going to squish it this way. Okay, so how it squishes exactly right now, we don't need to know, but just knowing that a number out in front is going to stretch it up and down. A number in front of the x is going to squish it horizontally. And then any number that we add or subtract on the end is going to shift it up and down. So since we are doing the sine of x plus 2, I'm just going to graph a graph that looks exactly like this, but then move it up 2 units. So I graph y equals the sine of x, so it looks just like our original graph. Okay, that's our parent graph. And now I want to shift it up 2 units. So I just take that and I go up 1, 2.
Wait, Mr. O'Connor.
Yes.
So everything that we like change about the graph, so you're always going to start with like either the sine of x graph or the cos of x graph, and then that's when you make the changes, right?
Correct. Yes.
Okay.
We will do other ones, but for right now, we're just going to focus on sine and cosine. Yes. Well put. Good question. All right. And hopefully that's helping you guys. I know there's some confusion there. Are there any other questions?
Can you go over what the variables mean?
Yep. So the variables, what you want to know is that this is called the amplitude. That's going to stretch it up and down. Okay. So for example, a number out in front stretches it up and down. So for this one, our original sine graph, would look like this, but then the 4 stretched it up and down. So it made it like, go up higher and down lower. So the number out in front changes the amplitude. The number, I missed it, sorry. The number in front of the x, that squishes it horizontally, or stretches it for that matter. So that's going to change it this way. So for example, if we had a number in front of the x, that's 6, our regular sine graph would go to 2 pi. It would look like this. But what that 6 does is it scrunches the graph so it looks like the blue graph. Okay, so the number in front of the x squishes the graph, or it can expand it also. We didn't talk about C, and we're not going to for a while. But D, that just takes the graph. It doesn't stretch it either way, but it just moves it up or down. So if there's a number added on the end, it moves it up or down. So for example, here, our original sine graph, which looks like this, sorry. Our original sine graph looks like the purple one, but then this thing is going to move it up 2. So we take that and move it up 2, and the blue is then our final answer there. All right, so really good questions, guys.